Welcome to a new test and teardown video. This time it's a DC power supply from GV Instek, and this one is GPS-3030DD. That means, of course, double display. This is a current model. You can buy this in a shop, online, or whatever you want, and it costs about 2,000 Danish kroners. They got a few different models. They got single-digit versions, and they got versions with mechanical meters. I think it was about 5 months ago I released another video about a similar power supply from another company, and they more or less use the same layout, the same switch size here. Everything is, I think it's more or less coming from the same factories. It's really the same. This one is, whoops, I need to be careful not to drop this one. This one is, of course, different. We got a huge heat sink out here, and this one is without a fan. And also we got a few features like programming external, so you can remote this with an analog interface like that. I think we should go straight to open this one and compare it to the other one. Ooh, they got some sexy screws. All right. I spent a few hours looking around in this unit, trying to find differences compared to the other video I released some time ago. And that other power supply is called Sagitta, and it is very different when it comes to implementation. But the fun thing is that the main schematic, the regulation, the relay controlling and all that kind of stuff, the way that it's driving, the pre-driver and the FETs and the emitter resistors, and the way that everything is made is more or less the same, and that is quite interesting. When I took off the lid, I found this cable dangling around, and it wasn't attached to anything. So that tells me somebody was in here, or this was not connected correctly. And then I was looking around to see where is it attached, and then I found it here. So yeah, and also I found another thing. Look at the white connector here in the middle of the picture right now, okay? That one is not pressed into the socket, but that cable goes to the analog remote interface, and since nothing is connected to it, I think that is why we don't see any problems. The rectifier is mounted on look at that, on a piece of aluminium, and it's quite thin. This is 2 millimeter, and it's full of holes. And then we got 2 more screws like that. What do you think about that? Why mount it here when this could have been mounted using that screw here directly to the heatsink? Well, that is one of the mysteries of the world I do not understand. But let's see how hot it gets when we load stuff. The two 3055 transistors, they are mounted correctly, and all that is done right. There's one little thing that could have been done better. See? They only attach power to the one of the nuts, that is collector, that is input. what they could have done is, as you can see here, there's plenty of space for the track to go all the way to the other side. And it could also go all the way in here to that one. So that means now you will have double contact, much better contact to your transistors on the other side, because that is a weak spot. Those screws, they will get loose, and also, as you can see, there's a little plastic spacer here. They also tend to change the pressure here over time. Of course, the two base connections, they are just in parallel, but the emitters, they are separate using the separate cables, and then you got the two emitter resistors here. Classic, done exactly as it's supposed to be. We also got room for two more capacitors, and that is maybe in the 5 amp version you need a bigger and better capacitor to handle the ripple current correctly. I think actually at 3 amps this could already be a little bit too small, so it could be a good idea. If you want to load this with a lot of amps for a lot of time, probably a good idea to put in 2 instead of 1 here. Could also fit a third transistor and see if that is better. We got yeah, another good thing about this circuit board here. We got really good silkscreen explain on all the trimmers, and everything here is really good explained. And you can also find the schematic of this power supply online, so that is easy. So it's super easy to repair these. And look at that, we got silk screens and explain on the bottom side as well. See, that is something fantastic. I'm really happy about that. The two digital LED meters, they need their own individual power supply. This is even done with a little fuse, rectifier bridge, and local regulator and all that kind of stuff. And see, the calibration points for your readout, amps, accuracy, low and high adjust. Wow. And the voltage meter here, the adjustment is up here, which is a little bit weird. Why isn't it somewhere else? But that's where it is. And all the other adjustments, that will be the minimum and the maximum current, and the minimum and maximum voltages, and so on. We also got 2 relays, so that is 4 ranges for the voltage. So that means when you dial on your voltage setting, you should hear some clicks on the relay, and there will be different tapping on the transformer to the rectifier and to the input side of the regulator transistors, and that minimizes heat loss in the transistors and also, of course, on the heatsink. And there is no fan here, and I really like power supplies without a fan, because fans, they have a limited lifetime and they just tend to fill up the instrument with dust and whatnot. So yeah, the only thing I can find that is a little bit funny, that is this. But we have a screw here, and we have a screw here to the chassis. So I think everything is going to be nice and stable when the chassis is mounted. So this is not a big issue. Let's do a little bit of measuring how this thing works. It's really easy to adjust the output voltage. The 2 potentiometers, they are so this is the coarse, and the fine is about a factor of 10. So this is about 3 volts. This whole a little bit less than that for the whole range here, and this one is of course 0 to 30, right? As you can see here. Oh yeah, we got those clicks, and this range kicks in at exactly 15. And we got 4 ranges and a tiny little bit of hysteresis. So when we're going from 0 to 8, that is, of course, this is the output voltage, right? So that is the first voltage range, and then the relays switch over at 8, 15.1, 22.8, and then you can, of course, go all the way to 30. So when you go down again, now you see the difference here, and that is the hysteresis to keep the 4 steps stable. And since it measures the output, it will, of course, also change the relays when you have a short circuit or a current limit mode, and because that is what you want. Voltage drops, but you still have a constant output current, and this way you have much less voltage to lose in your regulator, much less heat. Let's try and load this thing with 3 amps, and as you can see, the output voltage is still stable. I have done a little trick here. I got the thin wires here, that's the voltmeter. So I screwed those to the terminals in here, and those are the bananas I pull the 3 amps. But as you can see, voltmeter and ammeter accurate, and all that is fine. So here's my my 3 amps. That is, of course, 45 watts, right? So power consumption on the input side is 124 watts. So that means 79 watts are lost somewhere in this unit, including transformer, rectifier, and then the series regulator, and a little bit in the emitter resistors. So that is a efficiency of 36%. What we can see here is, well, let's just play with the current. So if I crank down tiny little bit, see, then I still have almost 3 amps, but I have 0 volts output. So remember, before my power consumption from mains was a 124 watts, but now it is only 69 watts. So it's not doing a very good job, because we still have a lot of volts over the series regulator multiplied by 3. But now we have 0.5 volts output and 3 amps. So that is 1.5 watts of output power, and the rest is lost. So I'm okay, I am losing a little bit less. Now I'm losing 69, and now I'm losing 79 watts. So it is not magic and all things here. I'm still playing with the 15 volt output and 3 amps. So now I have 122 watts lost, and I'm playing with this setting because it is very close to 15 where it change over. See, click just a tiny little bit down, and then I can crank up the voltage to 15. But now I'm just really close to the point where it changes over to the higher step. But now I'm losing only 99. Oh, I have 99 watts of input instead of 124 watts. So I saved 24 watts by running this tiny little click and then back to still 15. So the different voltage tappings on the transformer is just very important. I expect the rectifier to be equally hot all the way. That is, of course, current and nothing else. But the series regulator, see? Now we're back to 15. Ooh, now the transistors, they're gonna get warm. So what I'm doing here is the worst possible scenario. I am so close to a step, and then I am in the wrong step. Can you imagine what I'm doing here? So what is getting warm? Emitter resistors, they are running at 58 Celsius. They're very visible. That is just tiny little things. That's not really warm. The driver there is 56. And that is our rectifier bridge. It is running at 70 Celsius. And as you can see, the heatsink is only 46. But that is a shiny kind of surface, so you can't really trust. Oh, what you see here, that is really, really warm, 110. That is the fuse. And I expect we have a 3 amp fuse, and that is about to blow in a second. I'll of course have to go and check out that fuse. But we have a lot of voltage dropped on that. We can also have a little look on the voltmeters. Yeah. What is running warm here? 50 Celsius. That's this regulator. Hour. That is warm. So I expect we have a lot of voltage dropped on that, and of course the LED is running at a low voltage and quite a lot of current, so that's why this is running a little bit warm. To make good thermal pictures of transistors, you need to paint them. I actually saved some nail polish in weird colors. Click. What happened here? Oh, it's changing over. Oh, it's because I touched the voltmeter. Click. I am so close to the changeover, and temperature rise affected the point of change over, so that is a little bit funny. What I wanted to show you about the transistors, because I painted the top of the transistors, you can now count on the temperature. As you can see here, it is nice stable 62, but if you look at the shiny, as you see here, they're shiny on the side, and the rest of the stuff down here that is shiny, see, it is ice cold, just because of the emission factor from different kind of shininess. I also tried to paint right here to see if I could prove the heatsink material, if that was bad or the coating was not having a high emission. But as you see here, I can't see my paint. And that proves that they have indeed coated, painted, or treated the surface with something that radiate as much as possible, because my paint is not affecting the image. Of course, otherwise I would definitely call this a defect kind of heatsink if it didn't have any radiation, as you can imagine. So it is definitely working, and then thank God for that. So look at that. Oops, there's a lot of shininess here. So this is a close-up picture of the rectifier bridge, and it is 72, something like that, right? And look at the heatsink, it is 57. So there is a thermal problem here. From that part to that part, there's 20. What I could do is I could try and see if this surface here is what is tricking me. Let's just add a little bit here. And that top, see Is that visible? No, it is not. So that is 56. 74. Yeah. It's a little bit too hot to touch. Let's measure ripple and load dump. So here's 1 amp load, and you can see the ripple, but I am in 50 millivolt division, so it's not at all a problem. And when I release my 1 amp load, voltage goes up, but only about 120 millivolts, and it's very, very fast. And then it goes back to regulation again, and here we see no ripple. The noise you see here is because I got a router and Ethernet cables and all that kind of stuff going all over the place. So, but it is not that bad. Nice and stable load dump curve. And this is a load start, drop, and then it goes into the ripple and regulation mode again. So it's definitely a winner here. There's no sign or of anything unstable, so that's great. You can use this and you can buy it. Be my guest. I kind of like it.